What we want to do is we want to take the properties of real numbers that we've been discussing and use them to solve equations. And so, an equation are two expressions. We have a quantity and then an equal sign. And the equal sign is a statement. It says the left hand side, which I'll abbreviate LHS, is equal to the right hand side, which we'll call RHS. Right? Just because writing, you've seen my handwriting. This is probably the best. Now, it doesn't have to be true. When we get a statement, we then go, is it true or not? And in this case, 5 plus 2 equals 7. It's true. We will find that there are things that won't be true, and they tell us something about what's going on. But we can assume that if we're given some equation, it is true until evaluating it tells us otherwise. In fact, evaluating here, I'll complete this operation, and this says 7 equals 7. I took the left-hand side and I simplified it, and it showed me that the left-hand side equals the right-hand side, so this is true. There's some neat things that we can think about equations. If this quantity is equal to this quantity, well, if I decide that I'm going to take this and add 4 to it, to keep my whole equation true, I have to add 4 to the other side. In fact, the book's going to break down into different things we can do. It comes down to, and this works for almost all of mathematics, whatever you do to one side, of an equation, it's not meant to be a B, it's meant to be the side of an equation, you do to the other. Right? We do this in calculus, we do it in pre-calculus, trigonometry, algebra. If we make the assumption that these two things are true, if they're not true, that'll tell us something about what we were looking at. But if they are true, I can manipulate these things however I want, as long as I follow the properties of quantity and number that we did before. But whatever I do to one side to keep the whole equation true, I have to do to the other. Well, this really comes in handy when we put an unknown in. Now, for some of these, we're going to start off and we might be able to guess or have a method of, well, what plus 5 equals 9? Oh, it's 4, right? We might have ways of working there. But we want to do is we want to practice manipulating both sides so that we can isolate the variable. And so we work on isolate the variable. Is the main goal of all this. And so in this case, I look and I go, hey, I want x on its own, but I've added 5 to it. Well, how do I undo an addition? Well, that's a subtraction. So I subtract 5. But I've taken this whole quantity, whatever it is, and I've subtracted 5 to it. So to keep my equal sign true, I have to subtract 5 from the other side. Now 5 minus 5 is 0, so this goes away, and 9 minus 5 is 4. And that's the game we start playing. We start looking at how to make the left-hand side and the right-hand side equal. And once we set up some equality, we assume it's true. And we use all the properties of addition, subtraction, multiplication, powers eventually, and distribution, to isolate the variable, to get it on its own, because that's going to tell me what it was. And of course, when we do this, we always want to check. Now, when I check, I keep parentheses around my variable. That'll help me. And so I've put 4 into there, and 4 plus 5 equals 9. I work all the way down. My left-hand side is equal to my right-hand side, and I've solved the equation. This is what we call solving. Let's look at this and look at how we define it. We can add or subtract or multiply to either side of the equation. So anything we do to one side, we do to the other. So let's see here. If I have x plus 6 equals 1 minus 3. Now, we will work with word problems and figure out where these things come from, but I have something that I don't know what it is, and I'm going to add 6 to it. And we're saying that's equal to if I took 1 and I subtracted 3 from it. So first, I'm going to get this right-hand side simplified, like we did in the previous section, simplifying expressions. So 1 minus 3 is negative 2. And I'm going to keep my left-hand side as is. Now I want to write all my steps down. I want to keep track of where I was. That way if I make a mistake, it's easy to come back up and fix it. And also, I can look at where it's going. Well, at this point, I need to isolate x. Well, I've added 6 to x, so to undo that, well, the operation that undoes addition is subtraction, but I subtracted from my quantity, so I have to do it to the other side. These cancel. That's why we chose to do this. 6 minus 6 is 0. And negative 2 minus 6 is negative 8. But we always want to check. So I come back and rewrite this with a negative 8 in place of 6. I simplify my expressions. Negative 8 plus 6. Well, if I meant negative 8, move over 6. I get to negative 2. And we've checked it. I'm going to keep working some examples so we can see some things that happen here. Okay. We won't want to kind of, and this is why you get a good chunk of homework, is that we can say what's going on, but we really need to practice it to notice the patterns. So I'm going to have 2 times the quantity minus 4 times the quantity, the same thing, is equal to 10. Now, my left-hand side, I will keep the same, because I don't need to change 10. And it's okay if my variable's on the right-hand side. Well, I have like terms, so I'm going to simplify my like terms. And so 2m minus 4m is negative 2m. Well, I'm close. I simplified this, but I've got a multiplication here. Well, the thing that undoes multiplication is division. And so I want to divide by the exact same thing I multiplied by, which in this case is a negative 2. But whatever I do to one side, I do to the other. And so 10 divided by negative 2 is negative 5. Negative 2 over negative 2, anything divided by itself is 1. So that leaves me with 1m. Again, I want to check. So I'm going to come back here, and in parentheses, and now do you see why I like the parentheses? Right? It orders these nice and neat. And now 2 times negative 5 is negative 10, and 4 times negative 5 is negative 20. But a subtraction of a negative becomes positive, and 20 plus negative 10 is 10. So we have this ability to find solutions to equations or variables in equations if we undo all the steps. Let's do some more and look at the different patterns that can come out of this. So if I have negative 8 plus 6 is equal to some quantity divided by 3. I'm going to simplify the left-hand side, so I get negative 2 is equal to some quantity divided by 3. Well, this is a division, so to undo a division, I have to do the opposite, which is multiply by 3. And so 3 over 3 will cancel, giving me 1. Oh, but whatever I do to one side, I do to the other. I should write that step now, shouldn't I? And by choosing the opposite and undoing this, that leaves me with a, and my left-hand side becomes negative 6. And so now I've found the value of a. I'll come back here and I'll double check. So in parentheses, negative 6 divided by 3. So I'll simplify the left-hand side. That's negative 2. And that's also negative 2. So this checks. All right, we're going to have lots of examples because this can get complicated. Let's look at this one. So if I have 13 times a quantity, that is equal to 4 times the quantity 3x minus 1. Now notice in parentheses, we're treating whatever in here as if it's one number. Now again, when we're making equations from reality, this is saying that I multiplied something by 3 and then I took 1 away from the result. And that might be the process of how we build something, how we construct it, how we measure something. There's a reason we group this together. And then whatever that answer was, we multiplied by 4. Well, I've got to peel away. I've got to find some way to get all of my x's together. So I'm going to distribute the 4 to both terms. So I'm going to expand and simplify my right-hand side. So 4 times 3x is 12x. And 4 times negative 1 is negative 4. Now at this point, I have my variable on either side of the equation. So I want to get rid of it from one side. And usually I take the smaller one and I subtract it. So I want to get rid of 12x on the right-hand side. So what I'm going to do is I'm going to subtract 12x because that will get rid of it. But whatever I do to one side, I do to the other. And so I'm going to simplify my left-hand side. I have 13x's and I take away 12. I only have 1. Now because I chose these terms to be the opposite of each other, they're going to cancel out. And I get x equals negative 4. Again, I'm going to check. And again, I'm using the parentheses to keep track of what I'm doing. Let's see, 4 times 13 is 4 times 3 is 12. Carry my 1, 52. And it was a positive times a negative, so it's negative. And in here, I have to start inside my parentheses. So 3 times negative 4 is negative 12 minus 1. And that gives me negative 13. Whoops, rewrite that. And that gives me negative 52. So it checks. So you see, this can get complicated, but we can work on peeling away onion layers, so to speak, peeling our way to um, back to the variable. I always think of Shrek. Ogres are like onions. Equations are like onions. They have layers, and you just have to peel away the layers. Like when you're cooking, you pull off that crunchy outer edge until you get to the fleshy bit. And then maybe you have to pull off a layer or two of that. And then you got the onion you can chop up nicely. All right, I want to look at one more of these, and then we're going to look at how we talk about the things that make up equations. So we're going to have multiple things going on both sides of the equation. So I'm going to simplify the left-hand side first. So I'm going to distribute this across the parentheses. So negative 4 times x is negative 4x, and negative 4 times 2 is negative 8. And the negative 6 is out here. And then 2 minus 10 is negative 8. I'm going to continue to simplify this side, negative 4x, right? That's the only variable term. And negative 8 minus negative 6 is, oops, this was a 60. I think that'll be better. That'll give me an answer I can get. Sorry about that, but we'll just put my 0 in here. And because I hadn't touched this in the distribution, that's an easy thing to fix. Right, that's why I like writing my steps. If I make a mistake, I can usually go in and fix it. All right, so negative 8 minus 60 is negative 68 equals negative 8. Well, I'm still trying to isolate x here. So I'm going to undo this subtraction by doing an addition. But whatever I do to one side, I have to do to the other. I chose these so they'd cancel. So I'm left with negative 4x on my left-hand side. And I'm left with 68 plus negative 8 is 60. Now I have to undo this multiplication. And I'll do that by dividing by negative 4. And whatever I do on one side, I do on the other. And I'm going to write the rest of it right here. The negative 4 divided by negative 4 will become 1. So that leaves me x. And then 4 goes into 60 15 times. And dividing by a negative gives me negative 15. All right, let's check it. Negative 4 times negative 15 plus 2 minus 60 is equal to 2 minus 10. So coming over here, I'll do what's in the parentheses first. Negative 13 times negative 4 minus 60 is equal to negative 8. 4 times 13, let's see, 2, carry my 1, 52. Negative 50, and a negative times a negative is positive, right? Negative times negative is positive. Minus 60 equals negative 8. And I'm taking 60 away from 52, so it's going to be a negative number, because that's bigger than this. And the difference between 60 and 52 is 8. And so that checks. So we have a process of peeling our onions, so to speak. Let's look at some of the words that go around what we're doing here and how reality comes into equations. Because equations are models to predict reality, and we have to work our way through or back to it. And so there are words that are common for addition. We get a sum. We'll see that in a word. Plus, one thing plus something else. Added to. More than, right? We can more than something. Increased by, what's the total? We can also sometimes the word and can be used as an addition. And subtraction, right, we'll sometimes say is a difference. What is the difference between two numbers? We'll say minus, we'll say 5 minus 3. Sometimes we'll do it in reverse order. We'll say 2 subtracted from 8. Well, that would be, we'd write that as 8 minus 2. Less than, right? What is, if I have 12, how would I say that? 6 less than 12. I'm subtracting that way. Decrease by, less, 8 less 2, right? Take away. These are all words that we can see for it. And let's come down, well, there's some words for other multiplication. Is called the product. We can say times, right? 3 times 5. We're really, that short for is I've added 3 5 times, right? So that's where the word kind of comes in. We can say multiply. We can do some very specific multiplications, twice, which is 2 times, triple, 3 times, and sometimes you'll hear quadruple, which is 4 times. And there's specific words that we have for a certain quantity. Of will sometimes be used to multiply. And then division has its own words that come about when we're trying to describe what we're doing to something. We'll hear it called the quotient. We'll say divided by. Divided or divided by. Both are the same. We could say shared equally among. Right? If we're taking something and we're sharing it equally among. Per is a word used a lot for division. Divided into. And sometimes we'll hear 2 used, like 4 to 1 is a way of talking about a ratio, which is a form of division that we can do. So we can take phrasing and turn them into equations. I can say the sum of -3 and a number. Well, the number is my unknown thing. So I got -3 plus, and if you watch this week's video in the discussion, we tend to use x for the unknown thing. And there's a reason for that. So watch the video. It explains, it at least gives an idea of where it came from. Let's see, -5 decreased by a quantity. Well, the quantity is the thing I don't know. So -5 minus, again, we'll use the unknown thing as being x. And so what we have to do is take these sentences and turn them into expressions. And we'll keep practicing this so eventually we can take reality, describe it in words, and have those words describe the numbers for us, or the, I guess, equations. All right, that was section 3.2 I'll see you on 3 3.